Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 994, routing oranges. You are given m times n grid, where each cell can have one of the three values, 0 representing an empty cell, 1 representing a fresh orange, or 2 represent a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. So basically, if we find a rotten orange, we look at the 4 directionally adjacent neighbor. We look up, down, to the left, and to the right, and then to see if any fresh orange is placed in the 4 directionally adjacent cell. If there's any, they become rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. Let's take a look at the example 1. So at the minute 0, basically the starting state, there is one rotten orange on the upper left corner. At minute 1, so the adjacent fresh orange, so those two orange are adjacent to the original rotten orange, so they become rotten. At minute 2, so take a look at all the 4 directionally adjacent cell to the existing rotten orange. Let's say this orange has adjacent or fresh orange here and here, and then they become rotten. This orange has adjacent fresh orange here, because this fresh orange is adjacent to 2 rotten orange, so it's already become rotten here. At the minute 3, we look at all the rotten orange and then check the neighbor ones. So in this case, this rotten orange has a fresh neighbor, so it becomes rotten at minute 3. For minute 4, so there's only one fresh orange left, and then it's adjacent to a rotten orange. So that's why it takes 4 minutes for this grade. So to understand this question, so every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. It's simultaneous rotten. What does this mean? Let's say, for our example 1, we just had one rotten orange at the very beginning. What if there are 2 rotten oranges in the grid at the very beginning? After 1 minute passed, all fresh oranges adjacent to the 2 rotten oranges become rotten. So that's the meaning for simultaneous rotten. So in this case, it's actually a BFS instead of DFS. The idea is, let's first count the number of fresh oranges in the grid, and then we use the queue. Initially, put the initial rotten oranges at minute 0 into the queue. At every minute, we pop all the rotten orange from the queue, and then find their 4 directionally adjacent neighbors. Add these neighbors to the queue if the neighbors are fresh oranges. After the queue is emptied, check if there is any fresh orange left. If there is no fresh orange left, means that okay, all the fresh orange have become rotten. If there is any fresh orange left, let's say similar to the cases in the example 2, because that fresh orange is surrounded by the empty cell, so that fresh orange cannot turn rotten. So in that case, it's impossible. That's when we return -1. Utilizing BFS, the time complexity is m times n. So basically, every cell on the grid has been visited once. The space complexity can be up to O m times n as well, because we need to add element into the queue. So the queue size, the worst case scenario, the queue size can be m times n. Let's start coding. So basically, we count the number of fresh orange. We initialize that to 0. And then we initialize a queue, utilizing the Python dequeue from collection. And then we count the number of fresh oranges in the grid, and then also add the existing rotten orange that at minute 0 into the queue. To do that, we need to loop through the grid. So let's first get the dimension for the grid. Then we are looping through the grid. If the grid ij, if the cell value is 1, it means fresh orange. In that case, we increase the count for fresh orange by 1. If the grid value is actually 2, we add that to the queue. So basically, we are adding the rotten orange into the queue. So after that, we are popping from the queue. So we'll queue for I in length, in range length queue. So for doing that, we also need to track the time. Remember, we need to return the number of minutes. So in that case, let's track the total time and initialize that total time to 0. So for I in range length queue, so why we need this in addition to while queue? So can't we just keep popping the elements from the queue? Because remember, we want to track the total time at each minute. So only the neighbors that are adjacent to the existing rotten orange can become rotten. So that's why we want to utilize this for loop. So basically, we pop from the queue. So xy equals queue dot top left. Basically, let's pop the top of the queue. And then we check the neighbors. Basically, when we are pop the xy, which means the position for the rotten orange, so we want to check the neighbors and turn all the fresh orange in the 40 rationally adjacent neighbors into the rotten orange, and then add a newly created rotten orange into the queue. Let's say for nx, ny in 4 directionally, so x plus 1, y, x minus 1, y, x, y plus 1, x, y minus 1. If the neighbor is within the boundary, so which means nx is within the range of the grid. And then ny is also within the range of the grid. And then also only if it is a fresh orange. Okay, so within the boundary of the grid, and then also the orange is actually a fresh orange. In that case, we add them to the queue. So queue dot append nx, ny. We add the positions into the queue, and then we turn the fresh orange to rotten orange by update the value from 1 to 2. And then that's kind of the end of this for loop. In this case, we just increase the total time by 1. So which means, okay, we completed all the operation in 1 minute. So what operation have we completed? So basically, we first pop all the rotten orange before the start of this minute from the queue, and then check its neighbors. If the neighbor is actually a fresh orange, then we turn the neighbor into a rotten orange, and then add a rotten orange into the queue. So then we increase the time by 1. So in the end, when we finish visit all the oranges, if the count are fresh, so we forgot to update the count of fresh. Let's say whenever we turn a fresh orange into a rotten one, we decrease the count of fresh orange by 1. Let's say in the end, if the count for fresh orange is 0, we just return the total time. Else, we return -1. Let's run the code. Okay. So we didn't pass this test case. So what went wrong? Let me see. We initialize the number of fresh orange to 0 at the very beginning, and then we utilize a Q to represent that. So, and we initialize the total time to 0. At the very beginning, we just increase the count the fresh orange. So if this equals 1, as we traverse the grid, if the value equals 1, then we increase the count of fresh orange by 1. If the grid value is 2, we just append that to the queue because that's the rotten orange. So after this nested for loop, we have all the rotten orange put in the queue. That's the rotten orange in the grid before time 0. And we also got the count for fresh orange. And then we just pop from the queue. So while this queue is not empty, so we just pop from the queue. Let's say for I in range length queue. So while the queue is not empty, it means that, okay, we still have some rotten orange that we haven't checked the neighbors. So basically for every rotten orange, we want to check the neighbors and then turn the fresh orange in its neighbors to the rotten one. Basically, in that case, we just pop everything from the queue, pop all the rotten orange from the queue. So when we pop it, we check the 4 directional neighbors, x plus 1, y, x minus 1, y, x, y plus 1, x, 1 minus 1, as the new x and y. If the new x and the new y are within the boundary of the grid, and they are fresh oranges, in that case, we append this index to the queue, and then we turn the grid value to 2. And then we decrease the count for fresh orange by 1, because we turn a fresh orange to the rotten one. And then in the end, so we check to see if there is any fresh orange left. If not, we return the total time, else we just return -1. Okay, so our output is actually 1 orange more than the original one. So we got the total time. The total time, we start the time at 0. Okay, so it's super weird. For I in range length of Q, basically, if we are trying to execute it first, so at the end of minute 1, those two were added to the oh, I see what went wrong. So this is the first iteration, and then this is the second iteration, minute turn 2. And then this is third iteration, minute becomes 3. And then this is actually the fourth iteration. In the fourth iteration, okay, I add this rotten orange into the queue. But we do not need to pop this rotten orange from the queue because we already turned all the fresh orange into the rotten one. So we don't need to pop this one and then check its neighbor. So that's why our output is 5. The expected value is actually 4. I made a mistake here. So basically the condition is, okay, as long as the queue is not empty, I just keep pop from the queue. However, when I turn the last fresh orange into the rotten one and then add it to the queue, the existing queue contains this rotten orange. And then this rotten orange does not need to be popped from the queue and check the neighbors because in this case we already turn all the fresh orange into the rotten one. So there is no more fresh orange left. So in that case, we actually need to do the count fresh greater than 0. If all the fresh orange has already been turned into the rotten ones, then in that case we don't need to care about the other rotten orange on the board because in the grid, because all the neighbors for those rotten orange, if there is any fresh orange left, they have already been turned into the rotten orange. So that's kind of where I made a mistake. So let me rerun the code. So, okay, so it's actually a pretty efficient solution. So you can see here, I made a mistake initially on line 33 and then got a different answer than was expected. So then I try to debug the code. I first went through the logic. So basically I just checked the code line by line to make sure I didn't make any stupid mistakes. And then I look at the example and trying to reason through, like trying to walk through the code execution process in my head. So when you are when during the phone code interview, what you can do is you can also take the example that you output the incorrect solution and then trying to input into the code and then trying to get the intermediate result and work through the code execution line by line to see what kind of result you got. And then in that way, you can also do the debug.